Hi there, Algebra 1. Today we're doing 4.4, graphing a function rule. To graph equations that represent functions. What is the graph of the function rule y equals negative 2x plus 1? Okay, there's a couple different ways you can do this. Okay, I'm going to go -2, -1, 1, or 0, 1, 2. My x's. Okay, I'm going to plug that into this formula, 2x plus 1, to find out what my y values are. I put in -2 here. -2 times -2 is 4, plus 1 is 5. Okay, I put in -2 times -1 plus 1. That's going to give me 2, so that's going to be 3. -2 times 0 plus 1 is going to give me 1. -2 times 1 plus 1 is going to give me, well, -2, so it should give me -1. Alright, -2 times 2 plus 1 is going to give me -4, should give me -3. So my order pairs are -2, 5. So if I want to graph this, we can go over here, we got the room. Can I graph over here now? So, -2. Alright, it's going to be up 5. 1, 2, 3, 4, 5. Alright, -1 is going to be at 3. Okay, 0 is going to be at 1. 1 is going to be at -1. And 2 is going to be at -3. Like that. There would be my graph of that. Now, that's a linear equation, right? We can draw that, and we should be able to draw that without finding every point. But this is how you could do it that way. Alright, so we have the same thing going on here. Okay. Gotta make my chart again. Okay. Alright. So, gotta create a chart. I am once again going to go from -2, -1 to 2. 1, 2. Alright. And this is -1. So they're going to plug it in. So we're going to get 1/2 times -2 minus 1. We're going to get a -1 here minus 1, which is going to give me -2. We're going to plug in 1/2 times -1. So I end up with -1.5. Alright, then I plug in 0 here. 1/2 times 0 is going to give me 1, or -1. Plug in 1, so you're going to get 1/2 times 1 equals, we have -1. Alright, it's going to give me -1. you're going to get 1. You should get that. No, you should get this. Alright, so we have that. So now we need to create a chart or a graph like this. Okay, gotta create myself a graph. Alright. So, we have negative half. Right here, negative 1. So that would be my linear equation. Okay? Okay, graphing a real world function rule. The function rule y equals 146c plus 30,000 represents the total weight W in pounds of a concrete mix that carries c cubic feet of concrete. If the capacity of the truck is about 200 feet squared, what is a reasonable graph of the function rule? Okay, so at this point, alright, we want to know what is a reasonable graph of this function. This could be a fun one. Alright, so if we make a chart again, okay, we got up to 500 feet, which is going to be our feet in capacity. So, try to do my chart again. Alright, so C is going to equal 0. It's going to equal 50, 100, 150, and 200. My equation that I'm working with is 146 times C plus 3,000. Or 30,000. So 30,000 is probably what your truck weighs. Good. So if I plug in 0 here, I'm going to have 146 times 0 plus 30,000, which is probably 0 and 30,000. Alright, 146 times 50 plus 30,000 is going to be when I have 50 feet cubed of concrete in there. Typically you buy it by the yard, by the way. Okay. Probably going to need a calculator here. So, I would probably write 146 times 50, which is 7,300. So, that's going to give me 50 and 37,300. Alright. Take 146 times 100. Plus your 30,000 equals, okay, you can also take 146 times 150, and you're going to get 51,000, so my order pair would be 150 51,900. Alright, we can take 146 times 200. Which is that one? Okay, now you'd have to graph that. Alright, you get 50, you give me 100, get 150, 200. Alright, we're gonna go 10,000, 20,000, 30,000, 40,000, 50,000, 60,000. So, at zero, just with my truck, it was 30,000. Then I started putting on some feet squared, or cube, on my truck. I got 37,000 after 53, so we're probably about right here. Alright, after 100, we are about 44, about halfway through here. Alright, at 150, we are at 51,000, so just barely above here. And then 200, we are right about, right under the 60,000. Okay, that is what our function rule would look like. Real world situation here. Okay. Continuous and discrete graphs. Continuous graphs is a graph that is unbroken. So, the way I made my graph right here, this is unbroken. Yes, I went up by big chunks, but I did not make a break. A discrete graph is composed of distinct isolated points. Okay? They're off by themselves. I don't know why I don't have pictures of those. Maybe tomorrow during the lesson I will. Okay, it's in your book though. If you need some pictures of them, they are in the book. A local cheesemaker is making cheddar cheese to sell at a farmer's market. The amount of milk used to make the cheese and the price at which he sells the cheese are shown. Write a function for each situation. Wow, I really did that on this. Alright, so I'm going to have to look at my book because I got a feeling I do not have anything I need right on here. Don't know why. What I was thinking at the moment. Alright, so 1 gallon of milk makes 16 ounces of cheddar cheese. Each wheel of cheese costs 6. Each wheel of cheddar cheese costs $9. Okay. So we would have to make 2 different charts here. Okay. So, my first one here. Okay. So, Okay, I'm gonna have one here, and I'm gonna have one here. Okay? Now, I have to make these two graphs. One being what I made, or how many ounces I made, and based off of gallons, and wheels sold, and the amount of money. So, alright. Gallons of milk. Okay, so if I use 1 gallon of milk, obviously if I use 0, I'm right here. Alright, we're going to go up by 16. It just makes sense because of the fact that is what we're going to be going up by anyway. Alright, so if I use 1 gallon of milk, I made 16 ounces of cheese. If I use 2 gallons of milk, I'm going to make 32. If I use 3 gallons of milk, I'm going to have 48. If I have 4 gallons of milk, I'm going to have 64 ounces. Okay, now, if I use a half gallon, can I have something in between these points? Or a 4th gallon? Yes, I can make up stuff in between here. So this has to be a line going there. Now, over here, we are going to have rolls of cheese, or whatever it's called. I don't remember what it's called. Wheels of cheese. And we're going to have money from selling. Okay? So, each one of these we get $9. I'm going to go up by 9s. So it makes my life easy. Okay, so if I sell one of these wheels, I get $9. I sell 2 of these wheels, I get 18. I sell 3 of them, I get 27. I sell 4 of them, I get 36. Now, if I have this wheel all packaged up, all neat and nice and that, can I break it apart? Well, probably not. I mean, I could repackage it. But if I'm selling it by the wheel of cheese, I would just be selling it that way. So I can't have in between, so I'm going to have a discrete graph here because of the fact that I can't have in between points. In this one, I have a continuous graph because in between, I can have half of here, and I can make so many ounces of cheese. Whether that makes a wheel or not, I do not know. It doesn't give me enough information for that, but I do know if I cut my amount of milk in half, I can still do it. Graph each and decide is the function in continuous or discrete. The amount of water in a wading pool in gallons depends on the amount of time in minutes the pool has been filling. Okay? So, the thing about filling in a pool, so we'll make a graph for that one first. Okay. So my first one here is going to be time. Okay? And to be exact, it's going to be in minutes. So maybe in, alright, we got W equals 3T. T being time, I'm guessing, and W being the amount of water in there. Okay, which is going to be gallons. One minute, 2 minute, 3 minute, 4 minute. Will get us 3, 6, 9, 12. So times 0, I'm going to have 0. If I plug in 1 into my equation here, I'm going to get where it is 3. I plug 2 in here, W is going to be 2. Plug in 3, it's going to be 9. Plug in 4, it'll be 12. Okay, now, could I stop it in between time here? Yes, and there'll be a proportion of what's in there. Obviously, this should be a straight line. So, this one, I would say, is going to be a continuous graph. The cost for baseball tickets depends on the number of tickets bought. Okay, so we have this one. N is probably going to be the number of people going. C is going to be the cost of the total bill. So if I buy 1 ticket, 2 ticket, 3 ticket, 4 ticket, alright, it's going to cost me 16, 32, 48, 64. Alright, so if I buy 0 tickets, it's going to be 0, 0. If I buy 1, it's $16. If I buy 2, it is going to be 32. If I buy 3, it's going to be 48. If I buy 4, it's going to be 64. Okay, now can I sell a half a ticket? No, they're not going to let you in if you give them a half a ticket. So that one is thrown out. So this would be a discrete graph. What is the graph of each function rule? Okay. So, -2, -1, 0, 1, 2. I'm going to do number 1 first. Okay, so these are my x values, these are my y. If I put in -2 here, I'm going to make that a 2, which means that's going to be -2. Put in -1 here, I'm going to get 1 minus 4, which is going to give me -3. I plug in 0 there, I'm going to get -4. I plug in 1 there, I am going to get -3. And I plug in 2, I'm going to get a -2. So if I went and graph that, that's going to be that point. Okay, -2 is going to be at -2. -1 is going to be at -3. 1 is going to be at -3. And you have something that looks like this. This is what you'll usually get when you do absolute values. That's what your function rule would look like. It is nonlinear, just like the direction says. That is a nonlinear one. Okay? Pause if you need to. I'm going to erase to go to the next one. Alright. This one, you have your x and y again. -2, -1, 0, 1, 2. Okay? I plug in -2 there. We're going to get -2 times -2, which is 4. Plus 1 is 5. Alright? I'm going to put in -1. -1 times -1 is 1. Plus 1, so that's 2. I put in 0 there. 0 squared is going to give me 0, so I'm going to get 1. I'm going to plug 1 in there. I'm going to get 1 plus 1, which is 2. Put 2 in there, I'm going to get 5. Okay. This is where this one would be at. -1 would be right here. Positive 1 would be right here. These would be at 5. going to be a U shape. Anything squared is going to be a U shape. Okay? Now to the third. So if you need to, pause, you can do this. Alright, to the third here. So, I plug in -2. -2 times -2 times -2 is going to give me -8 plus 1, -7. Put a -1 then there. I'm going to end up with 1. -1 plus that, I get 0. Put in 0 in there, I'm going to get +1. Put in 1 in there, I'm going to get 1, I'm going to get 2. Put 2 in there, I'm going to get 8, I'm going to get 9. This is probably going to be my other one. So 0, it's going to be at 1 right here, -1, it's going to be right here, at -2, it's going to be 1, 2, 3, 4, 5, 6, 7. Okay, at 1, it is going to be 2. At 2, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's how you get that. Okay? That would be your last one, your last final one. I'm going to show you your homework. And there is your homework. Good luck.